We got numbers 5, 6, and 7 here on the board from your worksheet. We did 3 and 4 on the last video. And 5 and 6 are pretty easy because we had one of the variables set equal to t from the beginning. But in this one, neither variable is set equal to t. The closest thing was x is negative 2t plus 3. So from that, we got t is negative 1/2 x minus 3/2. Then we just plug that in to the other equation for t, and unfortunately you have to square that here. So squaring that binomial with them both being negative leads to all these results being positive. Negative times a negative is a positive. So then we distribute the 2 through here, and through here we distribute the other 2. This just comes down, and that's where I got when the other video finished uploading. So now combining like terms, this and this makes y equals, this just comes down as the only square term, plus 3x minus x plus 2x. And then 3/2 minus 5/2 gives me negative 1, right? Negative 3/2 minus 5/2 gives me negative 1, and then negative 1 minus 3 gives me negative 4. So that is number 7 when we're finished with it. Okay, checking my answer, that's wrong. My answer says this is minus 1. So I'm looking back, where did I make a mistake? And it was right here. I squared, this is right, but this 3/2 squared is not 3/4. 3/2 divided by 2 would be 3/4, but I squared the bottom but not the top, so this should be 9/4 here. 9 doesn't look right. So then this 9/4, again, in here. Oh no, now it's being multiplied by 2. 2 times 9/4 is 9/2, right? It's 18/4 or 9/2. And now 9/2 minus 5/2 is positive 2. It's 4/2, or positive 2. 2 minus 3 is negative 1. And that's perfect. All right, so number 8 is a lot like number 3 on the previous page. You're using the trigonometric identity of sine squared t plus cos squared t equals 1. So you get sine squared t, find out what that equals, cos squared t, find out what that equals in this problem, and then combine them and eliminate t that way. Because we're eliminating the parameter of t, that's what we're doing. And then number 9 is similar to number 4, so we're going to use that other trigonometric identity with secant and tangent, which I'm forgetting momentarily, but first let's get the each equation in terms of secant squared t and tangent squared t. Now I can derive the equation which I forget from the one that I don't forget. What I don't forget is sine squared plus cos squared equals 1. Divide the whole thing by cos squared. And I get tan squared plus 1 equals secant squared. So the equation for this whole thing, now I just plug in for secant squared and tangent squared, and I get y squared over 16 plus 1 equals secant squared t, secant squared is x squared. We could put this over 1 if we want to just be ready to put this in hyperbola form. If I subtract the y squared over 16 from both sides, I get 1 equals x squared minus y squared over 16. That's just, that last step might not be necessary, but it shows us which conic section it is. It's a hyperbola, right? All right, number 10 looks complicated, but it's really just adding one little step to the ellipse type problems we had before. So it's basically now we'll have an h and k in our final answer. I guess the trickiest part is when you have to square both sides of this, squaring x plus 1 over 4. You're probably tempted to FOIL this or something, but it just makes more sense to leave it in binomial squared form. So then we have x plus 1 squared over 16, y minus 1 squared over 9, and they add to 1. Number 11 and 12 are a different kind of problem where you have to use the parameter given as t equals y to write the rectangular equation, x equals y squared over 6, as a pair of parametric equations. And since the parameter is given in this one, I think it's easy enough to just plug it in to the equation in 11 and get this other parameter, So I think that's about, that's good for 11. But for 12, it's more complicated. They give us t in these terms. So again, this is my rectangular equation up here, just x and y in it, and this is my parameter t. So I don't know. I'm stuck. I haven't seen a problem like this before. A good thing to do when you haven't seen a problem, you're dealing with a problem that you haven't seen before, is try to do things that worked in problems you have seen. Just try some things that you do know how to do. One thing I know how to do is isolate a different variable. So what if I isolate x here? So if I multiply both sides by 3, I get 3t equals negative x plus 1. I can say 3t plus x equals 1. Just adding x to both sides there. And subtract 3t from both sides. So x equals 1 minus 3t. So now I could plug that into the top equation, perhaps, and get y equals, maybe I should put it as negative 3t plus 1. Squared over 4 plus negative 3t plus 1 plus 1. And then let's straighten that out. We get 9t squared plus 6, minus 6t plus 1 over 4 minus 3t plus 2. And then so that basically this becomes y equals 9/4 t squared. This becomes minus 1.5t. Minus 3t makes minus 4.5t. Minus 9/2 t. And this is plus 1/4. This is plus 2. So it's plus 2 1/4. Plus 9/4. So I want to leave it like that, and I'm going to check the answers in the website now and see if it's right. Well, it's not right, but it's close. So it looks like I misplaced the negative, kind of. Like, this negative was not on the... Or there is a negative, and I forgot about it. I think that's what happened. So it's y equals negative this. So y equals... So then I make everything negative. So this becomes negative 9t plus 6t minus 1. So then this becomes negative 9/4 t squared. And then this is negative 3 plus 1.5. So it's negative 1.5. Negative 3/2 t. And this is positive 2 minus 1/4. So it's plus 7/4. So that is what the answer in the back of the book says. I feel like there are some unanswered questions here about what does it mean exactly to do this? Are parametric, if I'm writing it as a pair of parametric equations, it seems like I'm supposed to do it so that both parametric equations isolate x and isolate y. So they both express x and then express y in terms of t. So I didn't notice that exactly before, but that's what the answer key has us doing here. So now obviously this is going the opposite way. We started with x and y isolated and then we combined it. And if you look at problems 5 through 10, all of them start with x and y isolated. So our parametric equations have x and y isolated and defined in terms of this other variable. So that's what we're doing in problems 11 and 12. And so saying one more thing, we decided we were just going to try something and see if it worked, and what we tried did work. Like we kind of got lucky. I didn't know exactly what I was doing, but I tried something. I said, well, I'm going to try to get it, redefine it in terms of another variable. Instead of y being by itself, I'll get, instead of t being by itself, I'll get x by itself. And that turns out is one of the things I'm supposed to do. And then I plugged that in and got y by itself. So there we go. I learned something. I think I'm going to stop this video now because 13 and 14 answers will vary. Well, I have gotten a lot of questions about them in class already in the last days of last week. So maybe I will look at them here. Nope, this is the end of the video.